There are 6 types of hard water treatment devices on the market, plus some combinations. They usually treat the cold mains water as it comes into the house, but you can also just fit them for individual devices like washing machine or a boiler. The main features to look out for are purchase, installation costs, maintenance costs, and also if you're fitting the device to a house which is in a hard water area and hasn't had any treatment before, does it remove existing scale? And also if you've got a tank in the loft, you want to find out how long the hard water treatment lasts for. Is it for hours, a day or two, or is it permanent? Before I talk about how you can treat your hard water, I'd just like to mention the Limescale dissolvers that you can buy. You just mix with water usually, perhaps put it in your kettle, heat it up, it'll dissolve the limescale overnight. Generally they contain phosphoric acid, which is a bit stronger than vinegar, which is acetic acid, but it's not that strong. For instance, it's the acid that's added to Coca-Cola. There are also tablets you can put in your washing machine with your laundry wash to prevent limescale build-up in your washing machine, such as Calgon, and I discuss the effectiveness of this in my chemical conditioner video. How do water softeners work? Well, they have a double chamber. The inner chamber contains resin beads. These are microscopic beads which have a large surface area. Around this chamber is the parts that you put salt in, sodium chloride. And how it works is that your fresh hard water from the cold mains enters the resin chamber, filters through the resin beads and comes out as softened water. Let's have a look at the chemistry. Calcium bicarbonate, magnesium bicarbonate are what makes the water hard. This is sodium chloride, the salt that you put in to work the water softener. It'll be easier if you look at the ions involved, because what's going to happen is a so-called ion exchange. Sodium ions are going to swap over with calcium magnesium. We start off with the resin beads coated with sodium ions. Hard water comes in, perhaps during the daytime, flows past the resin beads, and there's a kind of competition goes on. The more of these ions there are, they'll push the sodium ions out of the way, and these will stick to the resin beads. The sodium that's pushed out of the way is now in the drinking water that comes through here and comes out in our softened water. You can get water softeners which work 24 hours a day. They have 2 resin cylinders and they swap over, but the usual way of doing it is a so-called regeneration process which takes place at night. And how this works is that at night time, salt, sodium chloride is allowed to go into the resin chamber, and this time there are more sodium ions than calcium magnesium ions, so they're pushed out of the way. The sodium now attaches to the surface of the resin beads, and calcium magnesium ions are floating around in this water. The final stage of the regeneration process is that fresh water is allowed to flow in, washes out the resin beads, and this time this hard water flows out to waste. The water softener is all set up now with sodium ions coating the beads, ready to start the next day softening the water. One of the things you'll be advised to do if you install a water softener is to have a bypass. What this means is cold water coming into the house will have a branch off to one tap in the house, usually the kitchen tap, before the water carries on into the water softener. In other words, you have a supply of drinking water in the house. And there's a reason for this. It's essentially due to the sodium. Remember, what we're doing when we swap over sodium ions with these essentially is we're making sodium bicarbonate, which is now being added to the softened water, and this is sodium that may be of concern to people on low sodium diets particularly. But there are 2 other reasons. Sodium bicarbonate, as cooks on the bicarbonated soda bic, it says on here the main ingredient, sodium hydrogen carbonate. It's got a taste, and Some people don't like the taste of softened water. You've got the water hardness taste removed, and you've got the soda bit taste added. If your water hardness is 450 parts per million or above, you're actually putting so much sodium into your softened water, you're beginning to exceed the recommended safety level for sodium in water. And if you do have hard water 450 or above parts per million, you have to have a bypass installed. I've got one figure here for water of 300 parts per million hardness. If that's softened, a litre of it will give you 6% of your recommended daily allowance of sodium. Finally, there's a cloud on the horizon for water softeners, in that there are growing concerns about the amount of sodium being added to the wastewater systems. For instance, in the USA, some places have already introduced bans on the use of sodium chloride, such as the town of Hamburg outside Michigan, and all domestic properties and businesses have to operate their water softeners with potassium chloride. This is about twice the cost of sodium chloride, and I'm not sure at the moment why potassium chloride doesn't pose a similar problem to sodium chloride. This is the Wix water softener. You can see it's quite a bulky thing. This takes up this under worktop cupboard. They're quite expensive to buy, £400 or £500. You've got a fair amount of plumbing to do, especially with a bypass. That might be quite tricky. And then the maintenance cost is cost of salt. Annually, perhaps £70 to £100 for an average family, and the more water you use, the more salt you'll use. If you're interested in water softeners, I'd very highly recommend this WRAS leaflet, which gives in 4 pages a very good introduction to all the different aspects of water softening, and the link to this is on the website. My second water treatment I call partial water softening. It's my name for the process, which seems to be new in the UK. It's got 2 cylinders, a larger one which has resin beads, and a smaller one. I'll talk about this in a moment. Cold mains water comes into the resin chamber. A bypass isn't needed because salt, sodium chloride, isn't involved. The water flows past the resin beads and out into the second chamber. What do the resin beads do? They remove the calcium bicarbonate and turn them from bicarbonate in solution into microscopic crystals, which I'll discuss in a moment, and they leave the magnesium bicarbonate in solution. This is why they talk about a 4-star water softening process, because the magnesium bicarbonate is left in the water. So the water can still be a bit hard, but it's not as hard as untreated water. These microscopic crystals, when they leave this large tank, go into here. The job of this smaller tank is to remove the crystals. So this is the point at which the calcium bicarbonate is taken out of the water, and the water with magnesium bicarbonate, it carries on into the house system. It's also claimed that this process removes existing limescale, and the photographs they have on their website are certainly very convincing. Here's the element from an under sink water heater with a lot of scale on, and after 7 months or so the element is pretty clean. Costs. This price is quite high, but you can get one of these for 400 or so from eBay. The resin has to be replaced every 3 years or so. It costs about £130. This cartridge, which collects the calcium microcrystals, needs replacing perhaps every year, and that's a cost of about £20. I've looked at some of the comments on the internet, and people say it's a nuisance not knowing when the resin needs replacing, and also they say that the water can have a milky appearance, which is a bit off-putting sometimes. And also, to be fully covered by their own guarantee, you have to have a pre-filter added, so the water goes through the filter before it goes into the resin beads, and that's an extra cost. The partial water softeners, also the electrolytic, electronic and magnetic water conditioners, say they convert water hardness, calcium bicarbonate, not into calcite limescale but aragonite. You can see they're both forms of calcium carbonate, and when they're grown as crystals, you see that they have a different shape. This is kind of cubic and this is sort of hexagonal here. Calcite is a popular one in geology exhibits because you can see right through it and it gives you a double image. Here's an example. This crisscross line turned into a double line here. It's also known as a soft rock. You'll see in the sales literature for hard water that aragonite is soft, but it's calcite that's well known for softness, and the best example I've come across is this sculpture of a woman giving birth. It looks like a modern sculpture, but in fact it was carved 22,000 years ago in the Ice Age in France, presumably with very primitive tools, and I think the softness of the mineral is indicated by the softness of these shapes. It's 8 centimeters high. Now, aragonite is actually harder than calcite as measured on the Mohs scale, which is a way of measuring the hardness of minerals. So why is aragonite thought of as soft? Well, crystals like these, they take a long time to grow, and we're talking about years. When hard water is treated, the crystals grow fast, and typically when crystals grow fast, they grow small. These are photos of aragonite produced by hard water treatments, and this line here indicates the scale of the pictures. Imagine drawing a line 1 millimeter long. Well, these lines are 1/100th of a millimeter, and that perhaps gives you an idea of how small these crystals are. These ones are in clusters. And this gives a clue as to why aragonite is soft. The best comparison I can give you between the two forms of calcium carbonate with the frozen water. On the one hand, we can have solid, hard sheets of ice. On the other hand, frozen water as snowflakes that settles down that layer of soft snow. With aragonite, you have a picture of little microscopic clusters of crystals floating around. If they aren't just washed through the system, they do settle down to form a soft layer which can be easily wiped off. I should say that the process by which aragonite is produced by the hard water treatments isn't very well understood at all, and nobody seems to really know how it happens. Water softeners, also the electronic treatment devices and one of the magnetics, all claim to remove existing limescale, and this is the explanation. When these devices remove the calcium bicarbonate, the system, which is a kind of a seesaw, it acts to restore the balance. So if there's any carbon dioxide in the water, it will react with limescale, the calcium carbonate, to make calcium bicarbonate and restore the balance, and this limescale gradually gets dissolved in the process. What's effectively happening is that the treatment devices take away the calcium bicarbonate from the water, but a little bit more is put back in. So until the limescale is all gone, the water is being made a little bit hard again. But this process can take weeks, if not months.